On my way to work this morning, I saw a couple of hot air balloons off in the distance, and it made me wonder, how big are those things? Let's estimate it!
Fermi Estimate Friday!
This problem is actually a fun one because there are a lot of variables that I don't actually know, but I can get at them by playing a game of high or lower. What are the extremes? How high could it possibly be versus how low could it be? And finding somewhere in the middle. It's also fun because in order to find the middle point, I would normally just take the average, adding the two numbers and dividing it by 2. But because some of these numbers are off by more than a factor of 10, I'm going to take the geometric mean, which means I multiply them together and then take the square root. Things float because of buoyancy. When you put an object into a fluid, you have to displace that fluid to make room for it. But basically that means that that fluid is then pushing against you to try to get back to where it belongs. If the weight of your object is less than the weight of this displaced fluid, you're going to float. The same is true of a balloon. So objects that are less dense than the gases around us will tend to float. For a hot air balloon, the heated air is less dense than the cold air. The relationship I need then is for the weight of the displaced air to be greater than the weight of the air inside the balloon, as well as the basket, the people, and the nylon skin. The density of air changes with temperature, so I need to know the temperatures. I know the propane heater will heat it above 30 degrees Celsius, but also that the nylon would melt at about 220. So I'll pick about 80 degrees Celsius as a working temperature. Since the density of air at room temperature is about 1.2 kilograms per meters cubed, I'm going to say the heated air is about 1. So the difference between these is 0.2 kilograms per meters cubed. So now I need the mass of the people, the basket, and the nylon skin. For 4 people, let's say 800 pounds. I've seen people pull the basket and skins off of the back of a van, and the shocks responded much more than just 2 people jumping out. So the mass of that has to be greater than, say, 400 pounds. But the load capacity of a typical van is about 2,000 pounds. So I'll say the total equipment is about 900 pounds. Putting this all together, it gives me about 4,000 cubic meters. Cubic feet are about 30 times that, so that gives me 120,000 cubic feet. According to the internet, I'm a little high, but I'm definitely in the ballpark. Thanks for watching.